There we go. No, that's good. This is a minor thing, kind of minor thing that I forgot to talk about when we were multiplying integers. So that was back in section 1.3, I think. Area of a rectangle. You might occasionally see those. Area of a rectangle is the length of the rectangle times the width. And volume of a I'll just call it a rectangular solid, like a shoebox shape swimming, a regular old rectangular swimming pool. Um, any kind of, most boxes are a three-dimensional rectangular shape. So the volume of a rectangular solid, like a shoebox or a box of butter or something, is going to be the beginning of the area, length times width, and then times the height of that box. Because I know I have a homework or a quiz problem that has a volume of a swimming pool, I think. So I just wanted to make sure I showed one. So let's say my friend has a pool. She does has a pool, all one depth, shaped like a rectangle. The length is. I also haven't been doing much story problems, so it freaks people out in the beginning. So I just stay away from them the first couple days. Let me think. I'm thinking of my friend's actual pool. It's probably like, I bet it's not this long, but it feels like 20 yards. The length is 20 yards. The width is, well, let's make it easy, 10 yards. And the depth, and I'll just keep this all in US customary, not in metric. The depth is 6 feet. Now, if it was all one depth, it wouldn't be all over your head. Because what about the kids? Let's say the depth is. I'm trying to think of one that'll come out evenly. 5. 5 feet, still too deep for the kids. Well, 4 foot. We can handle this. Okay. Find the volume of this pool. Now, this is the swimming pool problems. This is why I picked this one. Are a little bit confusing because if you've taken science or anything, or remember your liquid volumes, like you might wonder if they're asking how much water is in there. But no, I'm just trying to find out the cubic feet. Let's put it all in feet, and then we'll find the cubic feet. So the length times width times height. So the length is 20, but we want it all in the same unit. So 1 yard is 3 feet. So that would be 60 feet. So I line out my variables. Sometimes people get a little freaked out with if there's a lot of words and a lot of variables. So that's one of the things we really practice that a lot in here, not in a scary way, but we just get more and more used to it. So if 10 times 3 is 30 feet wide. So you'll see what I mean by the end of the session. You'll be all like, oh, piece of cake, I know. But I'm just giving this strategy if you have story problems. Kind of line out your variables, then remind yourself what your formula is. I'll just write it this way, LWH, length times width times height. And so then we can go down here. There's still some room. So that we'll keep it all in the same unit, 60 feet, 30 feet, 4 feet. And then we'd write cubic feet or feet to the third power, or you might see it as CU feet, CUFT, cubic feet. Anybody want to tell me that answer? You can. Jumping right in with it, huh? Today's a pretty easy class day because I'll go through the PowerPoint, then you'll go in and do the quiz. So I'm not going to be too demanding of you. But tomorrow, very demanding. No, I'm just kidding. Tomorrow there's a lot of interaction because we'll do some group activities that are fun. Get up and move around, walk around in wherever space you are. So we'll keep our answer in cubic feet. And when you get it, just message me or you could say it out loud. Yay, good job. Oh, I have another little message here. I saved the chat in case you're wondering, like, oh, she never responded to me. Did she get my extra credit answer? I do. I double check before I leave class, before I log off. Make sure everybody has their points. And I also save the chat most days. It's supposed to automatically save, but the Zoom is a little glitchy sometimes. So, and also, let me pop this in here, see if it'll let me. Oh, it's letting me today. That's great. So the reason it's cubic feet is because this was feet, this was feet, this was feet. So it's really feet times feet times feet. So you could put it as feet to the third power also. That means that's another way of saying cubic feet. Oh, it has to have the answer on it though, doesn't it? 7,200 cubic feet. Here, so there's our answer. I don't usually use this whiteboard with the keyboard because it's harder to look at, I think. Oh, just turned it all red. Well, just went to highlight the answer, but oh well, that's fine. Anybody have a question about that one? I got about 7 people answering me. That's so great. Okay, one moment. Well, I'm going to pull up the PowerPoint, but I have 2 little messages in here I have to look at. Alrighty, let's go on. Oh, someone just asked me if that was the first slide. I did put this up earlier. This. And several people put in some great affirmations. And I also posted the puzzle. Today's puzzle is 4 points extra credit, and it's this. So if anybody came in a little late, that's okay. Just screenshot that or look at it later. You know, it'll be in the class video. I forgot to post the class video and email it to you all yesterday. I apologize. I got a little distracted teaching from my parents' house. I'm going back home this weekend, so I'll be back to normal. But if you ever notice something I forgot to send or open or post, feel free to text me or call, email. I'm grateful. That's fine, Valerie. All right, so now we are going into the Moodle to look at the PowerPoint for section 1.5. You would think we are going into the Moodle. I was all logged in and everything, and I just closed it. one of those days. Is it super hot where everybody is? I hear it's been just crazy hot, especially like over by Eagle Butte and stuff. I'm just making conversation while I do this. There, now I'm at the screen I started at and then closed. If you notice this, if you've looked at the Moodle, most of you have checked in. I can check when you've been in there, you know. You might be like, how come we only go to day 6, then 9, then 15? That's because sometimes I go faster, sometimes slower than I planned. Or like tomorrow we're doing an activity because we haven't had a chance to interact much in private, like you know, in your own breakout room. And I hadn't planned to have the activity tomorrow, but now I'm going to change it. So I changed these up a little. I only open them like 1 week at a time usually. And day 9 and day 15 are the midterm and the final exam. So I just have them up there so you know in advance when those are going to be happening during class time. But let's scroll down to look at, open up there's day 2. Day 3 was yesterday. See, look, that's what, my bad right there. I have the old recording from February, so I'll fix that. I mean, you could watch it if it still exists, but I wasn't uploading them to YouTube during the school year. Then there's the PowerPoints. Then here's today, PowerPoints for chapter 2. See what I mean? I'm not going into chapter 2 till tomorrow, so I'll modify that a little bit tonight. But what I wanted to look at is the chapter 1, section 5 PowerPoint, just so you could see what you have access to. These are just the PowerPoints from the textbook. I didn't do anything fancy to them, but some people really like them. So I told the class on the second day, I think, or the first, how you could find the e-text in WebAssign and click through each section. And that's nice too. That's not like reading the whole section of the book. It's kind of shortened. But you also make these PowerPoints available to you that the publisher gives to us instructors. Because you know, some instructors don't know what to say, or they don't have a lesson ready, or they're nervous. So, and some students really like PowerPoints. So there's times when I use a lot of the PowerPoints, depending if a class really likes it, then we do. But we'll see if you really like it. Maybe I'll do a quick poll at the end, see if it was popular, or if you like when I'm writing on the whiteboard all messy and you're sending in answers, because that's it's all the same to me. I mean, it's all different, but I don't care. So exponents and properties of real numbers. So we just, order of operations is this section, and it's, hold on, I'm just going to scroll down and show you. We're not going to the properties. So we just go to, well, I'll show them to you, but you don't have to memorize them. So it goes to slide 14, but you'll see what I mean. It's pretty quick. Does anyone have a comment or question before I start? Also, some people, hopefully not me, when some people teach with a PowerPoint, they just like na 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 sing song, la la la, they're just reading the slides. And for me, if I'm in a class or a meeting when it's all PowerPoints, I just zone out. There's new presentation software like Prezi and things like that. They're a little bit more circular for me that work better. But what the heck? They've got a typo in here. Oh well. So we'll be writing in exponential form, which we started doing yesterday. Evaluate exponential expressions. Evaluate using the order of operations. And this part, the identify and use the properties, it's not required, but I'll probably just skim through it so you see them, you know where they're located. They'll come up again in chapter 2. Exponent. You know, this was the answer on Jeopardy yesterday. I don't think it was a taped one. My parents were watching it, and that was one of the. I mean, that was the question, right? The answer was the small letter that signifies how many times to multiply, like something like that. I wasn't even really listening, but then my dad said exponent, and I was like, oh, good for them putting some math in there. And I will show the nerdle too at the end of this because I promised that before. So multiplication is one thing, repeated addition is another. That's what they're showing the difference of. Repeated multiplication, right down here. Get my little pointer going. Repeated multiplication, that's different from repeated addition. This, you could write this as 4 times 7 because it's 7 plus 7 plus 7 plus 7. This is not 4 times 7. So this is 7 to the 4th. This is 4 times 7. There's a difference between those. So we always try to touch on that in case anyone's confused about that. We call 7 the base and 4 is the exponent, and it tells you how many times to multiply that base by itself. And we could also call it to the 4th power. See what I mean? This goes kind of quick. This is a classic one. These are both. Oh, wow, they have that written wrong on there. Okay, they have something written wrong on there. See, they're trying to show you that -5 to the second means -5 times -5. So that would be positive 25. But there, -5 squared, you could also say squared or to the second or to the power of 2. -5 squared means negative and then 5 times 5. Just like if you remember we did with the absolute value, when you had a negative outside those absolute value goalposts, that negative carries along and stays. So go back to my spotlight. Now that I fixed that, it came back. So there, see that negative stays here on the outside, and it should be here right there too. Oh, that's interesting. I've never taught with this particular PowerPoint, as you can see. That's interesting. I'll have to write to them and say, hey, I'm going to fix it again because it's making me crazy before I change the page. If anyone has a question about that, most people do. Most people think I'm wrong, but you could enter in a calculator now if you entered it perfectly the same, like parentheses, -5 to the power of 2, and then you enter in a calculator just a negative and then a 5 power of 2 with no parentheses. It should, most calculators do it right now. So keep that in mind. It's a classic though, like it'll come up on the midterm. I'm not sure if I put it on the quiz or not. I forget. But just be ready. We might even practice a couple. Get away from that page. There. Okay. Now here's some practices. 2 to the 5th would be when they say rewrite as a product or expanded notation. That's when you go 2 times 2 times 2 times 2 times 2, and then the answer is 32. Always somebody's going to say, but isn't it 5? Like that just feels like the natural answer. So if you're thinking, I mean, not 10, isn't it 10? Not 5. Isn't it 10? No, it's 32 because it's 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32. So, and then even with fractions, we do the same thing. So if, and that's not, it doesn't need to be intimidating either. Actually, fractions raised to a power. And they have that parentheses that tells you take the whole fraction times the power. That has to be there for us to go to that step. taking that 2/3 times itself, 4 of them, 4 factors. Then we multiply and get a fraction answer, and then leave it like that. And that's fine. Here's some more examples. You can see a negative to the 3rd power. Negative times a negative is a positive. Then times a negative goes back to negative. So we're using those integer multiplication rules that we worked on the 2nd day. And then this one, there's 4 factors of a negative thing, so it's going to turn positive. There's just a rule of thumb if you like that kind of thing. If the base is negative and the power is odd, your answer would be negative if you had the parentheses there. And if the base is negative and the power is even, your answer will be positive. But then this one they did right. Thank goodness. I start worried. So negative sitting outside with no parentheses. See, there's a difference. That's why those shows like Sesame Street, one of these things is not like the other. They look kind of similar, and people might not notice that this is a totally different statement right here. So just watch that. That's like a little bit of a quicksand for algebra students. So I'll keep reminding you of that too. But keep that in mind, and that negative stays outside, still just slides right on the answer of 81. Anyone have any questions about those yet? Now we've got 10 students here. Hooray! Almost 4th of July weekend, huh? Almost too hot and dry for fireworks. Oh, what are we gonna have to do? We have to go to do them on the lake, huh? That would be fun. Gone to some fireworks over the ocean before? That's pretty fun. Or over the over the East River in New York City by the Brooklyn Bridge. But anyway, I like them anywhere, even in my yard. So here's an example of that volume situation. A truck can transport a load of motor oil that's 6 high, 6 wide, and 6 long. So like I was saying before, in story problems, just kind of filter out what you need. We need to know that it's going to be a box shape or a cube. It's a rectangular solid that's a cube, same size on length, width, and height. And then it says how many quarts can the truck transport. So we know that the cases are 6 by 6 by 6, and each case has 6 quarts. So the answer is really going to be 6 to the 4th power right there. So this is length times width times height. That'll be the volume. That many cases times 6 quarts for each case. So you'd end up with 1,296 quarts. I think when these get wordy, I know that they distract people. Not everybody, but some people get like, just skip them. But the whole point of math, in my opinion, the best thing about math, well, I like a lot of things about math, but one of the best things about math is that it helps us make sense of real life. It helps us solve real life problems that might be too hard to do in our head. Like a lot of people would be able to figure this out like just off the top of their head, right? But as they get trickier, then we can use our math skills, so especially algebra. I'm just going to keep on going, but stop me if I'm putting you to sleep. Order of operations, you might have learned, please excuse my dear Aunt Sally, or something like that another teacher might have made up. And that PEMDAS, like my students in New York made up a little rap song about the PEMDAS. PEMDAS, they'd like drum on their desks. That was before I knew about my dear Aunt Sally. I had been teaching in Africa, and then I was teaching in New York, and I never learned any of like the American tricks that we use. But anyway, the P for sure goes first. Parentheses, work simplify inside there. Clean up your exponents. An expression just means like a mathematical statement with no equal sign. Like 5 to the power of 2, that's an expression. Or 8 times 7, that's an expression. Or 1 plus 1, that's an expression because there's no equal yet. It's just like an idea that has no equal yet. Then we multiply and divide as you hit them from left to right. And that's where the PEMDAS confuses people because a lot of people learned to go through and multiply first and then come back and divide through. But no, you just hit them as you do them as you hit them. You'll see in our examples coming up in 2 slides. The same with the adding and subtracting. And I know a lot of you already know this, so here's the please excuse my dear Aunt Sally. Mnemonic. Mnemonic is what it's called there. Mnemonic. Okay, so now I'll just talk through this one. Usually it does like this. Oh, I know what. Hold on. Just a second. I know why it's being like this. There we go. That's better. Ha! All right, everybody. Give this a try. Grab your pencils or your pen and your paper. I usually say do or do not. There is no try. But oh my gosh, we watched that series about what's her name? Oh, I forget what her name. Elizabeth Holmes. That was her name. Ugh. That was one of her slogans, and she had it all over the place. So now I don't like it as much. It's a Yoda quote, but okay. So they did the first step. They did what was in parentheses, because that's the first thing. Next, you're going to do the exponent. So next, work the exponent. Then clean up inside that bracket. Then subtract from 7. So that'll be our steps. So if you want to do it yourself, go ahead. I'll check the chat. And I will ask people I'll ask a couple of people some answers like I did yesterday, but not like the first practice one. So let's keep going. Good job, those of you sending answers. I love it. Let's get this going. So 15 plus 8 was 23, and then subtract 23 from 7, and you get negative 16. Oh, you were right, Tommy and Valerie. See, I was wrong. I was like, I think it's negative 6. I was trying to do it in my head. So good job. That's excellent. And if anyone got negative 6 like me, don't feel bad because you could always go back and check like, oh yeah, no. Like when WebAssign gives you an extra try, if it turns out wrong, like if that had happened to me, I would take out my pencil and slow down. Good job. Any questions about that one, anybody? All right, here we go. Practice problem B or example B. 36 divided by parentheses, 3 squared times 2. So we'll do that first. The parentheses, minus 6. So inside the parentheses, there's an exponent. So see, sometimes they're sort of like layered, like a pastry or something, or they're embedded. There's little something filled in with like filling in a donut. Like there's some filling in that parentheses that needs to be dealt with first. So everybody else just hangs out and waits. And then you'll go divide and then subtract because dividing comes before subtracting, even if it wasn't from the left to the right. So I'll wait if you want to answer that one too. And meanwhile, actually, while you're working, let's see if it'll let me write on here. That word that on a couple pages ago, there was that word that says, please excuse my dear Aunt Sally, is a mnemonic. I was thinking that mnemonic. That's how it's supposed to be spelled. Mnemonic. Mnemonic. That just means a way of remembering something, kind of like Roy G. Biv, if you learned that for the colors of the rainbow, or there's one for knowing the planets in the our solar system. So mnemonic, just FYI. Because they had it spelled like PNEU, which is like it has to do with filling something up like tires, pneumatic tires, or pneumonia. That's filling up something up. It's a whole different root word. Okay, enough time for you all to do that problem, huh? Great, good job. Yes. All right. Let me clear my mnemonic. And here we go. So -4 was correct. High fives. Pat yourself on the back. Good job. And if you didn't get it, check your work. Ask me out loud or in private. Just make sure you're on the right page, okay? When I haven't rambled on too much about when I was a student. Since today's lesson's so short, I will briefly. I was very shy. I didn't ask questions. I was pretty bright, so I usually could get the answers even if I didn't listen to the teacher. But sometimes, and I'm not saying this is good. This is probably why I ended up to be a teacher because I don't think that was good. I should have like asked questions and not been so ashamed to not know the answer. Like that's dumb. But and I also used to like just kind of space out in class sometimes and then teach myself the stuff later. Which that can work sometimes. That'll work. But if you're getting stuck and getting lost, the more you get lost, the harder it is to teach yourself later. So that's why I try to make sure people are on top of it as we go along. It feels the best that way. Math does. Everything does. If we can't always stay on top of it though, but it feels good if we can. Okay, this one I have all my toolbars in my way. So we would need to work the parentheses first, common denominator, work the tops, then multiply. So I'll wait for people to do this one also because we just got fresh from all that fraction work yesterday. I also had I had only one horrible math teacher who was like a snob and was mean and rude if I didn't know the answer or just assumed I didn't know the answer because I was a girl and cute too, I thought, in high school. And like busy with lots of things like boys and games and activities, and not always like wanting to nerd out with math. But my teacher just such a snob and just had to be a certain way. And then he'd just humiliate me if I didn't know the answer, like I said. And oh, those teachers just wreck it for everybody. So there's always, actually, I was at my reunion Saturday, and one of the guys who I used to really dislike in that class, because the boy would always answer and the teacher would always call on him, and they were like having a bromance or love fest or something. I mean, not really, but felt like that. Like there's 30 of us in the class, and just this one kid is always the teacher's pet. I just couldn't stand him in high school, that kid. Well, he's nice now. It's no big deal. And he wasn't shocked that I'm a math teacher. But anyway, so I did, so there you go. I just rambled on a little bit to give you some time. So that'll be 5/12 times 8/3. And we can cross cancel. Sometimes my slideshow does not proceed when I want it to. There we go. You can cross cancel the 8 and the 12 to 2 and 3, huh? So it should be 10/9. Whoops. Back that up. No, they didn't do the cross canceling. But that's okay. They didn't reduce either, did they? Unless it's under my toolbar. No, how about that? So
Hey,
cross can.
real
Oh, go
quick,
ahead.
Jen,
Yeah.
can you really quick, can you go over how you cross cancel again real quick?
Yep. Mm-hmm.
Thank you.
So I was trying to get my little tools out here. Here we go. Let me do a draw line. Okay, 8 and 12 are both divisible by 4. So, whoops. No, that's not going to work. So 4 into 8 is going to be 2. I'll write it on the next, on another space. And 4 into 12 is going to be 3. So it's going to end up to be 2 times 5 on top. And then on the bottom, it's going to be there we go. 3 times 4 into 12 was 3. There. So it's going to be 10 over 9. 10. I'll put a line there over 9. See if I haven't. Oh, I haven't. I have a line I can draw here. There. And then that would equal 9. 9's smaller than 10. So we're going to end up to have 1 and 1/9. And that's okay because 40, let me put it over here too. They didn't reduce 40/36. Just some slacker made this PowerPoint. Now you see why I don't always use the PowerPoints. I should probably look through it first sometimes. I usually do, but so 4 goes into 40 and 36, doesn't it? So that's, you could put equals over here also. 10 over 9 equals 40/36. If you just reduce the top and the bottom, divide 4 into the top and the bottom, you get 10/9. So they just didn't finish that one, but that was kind of cool though. Any other questions, anybody? Does that make sense?
Thank you. That helped a lot.
Good. Okay. You're welcome. Anytime. So you'll see different kinds of problems too with order of operations. Like there might be some action going on top of a fraction bar or a parentheses or an exponent or mix and match of those things. If any of you come upon something that you don't know how to deal with, just let me know or send me a screen. Some people send me a screenshot sometimes. I'll be like watching TV with Neil or something, and we'll get some math problems coming through, and we could just work them out that way, or we could jump into the Zoom. But sometimes people take a picture of the web assign and they're like, "What is it asking me? I don't remember." So if I didn't do enough examples today, then just feel free to ask me or get an extension on the assignment. We could talk about it again in class tomorrow. And then this is the part that I was gonna do pretty briefly, the properties. I love the properties, but honestly, just memorizing a whole bunch of words is not very effective. And so I don't test on this. We don't test on it, and none of us instructors at OLC test on it at all anymore. But I use the words a lot, so you'll get used to hearing the words. This I was going to say semester, but during this term, this summer term, you'll get used to the words if you take algebra from me again or Monica. I think Warren uses the language a lot too. Ida does, but you'll hear the words a lot. So I just want you to see this is where they're located. And I'm just going to briefly explain what they mean. So these are all kind of the rules of the game. You could you could add backwards and forwards or multiply backwards and forwards and get the same answer. That's the commutative property, like a commuter goes back and forth to work and to home. So we can remember it that way, commutative. Associative has to do with the parentheses. So who you're associating with or your known associates, right? Well, it's like that. So A and B are together here like a couple. They get worked on first and then C adds in. But in addition, it doesn't matter what you work on first, it'll get the same answer. Same with multiplication. So those two have the special powers of commutative from the last screen and associative. So adding and multiplying have those powers, not like exponent powers, like superpower, but um, subtracting and dividing don't. So they don't follow that rule. So it's kind of interesting, but you'll see what I mean when we're doing our actual math work later tomorrow and next week. I talked about the multiplicative inverse and the additive inverse yesterday because I remembered that it was on one of the assignment questions. So I'll start with number 6 though. The additive identity means that's 0, the number that has no effect on your identity. If you add 0 to something, it's still that thing. Like over here, they added 0 to 3, it's still 3. So the identity for addition is the number 0. And the same idea with multiplying. If you multiply something by 1, it keeps its value. And so that's called the identity for multiplying or the multiplicative identity. So that is 1, the number 1. And we use these all the time when we're solving equations. We use these properties sometimes without even thinking about them, but I'll mention them by name while we work through them. So you'll just start to like kind of digest that into your hard drive naturally without memorizing. That's my favorite. So then the additive inverse I talked about yesterday is the number you add to something to reach 0. So it's really just its opposite. So the opposite sign of 3 is -3. So -3 is the additive inverse of +3. That's all there is to it. And then the multiplicative inverse sounds more complicated. It's just the word though. It's the number that you multiply by something to get back to that identity that I just mentioned. You want to get back to that identity of 1. So if you were stuck with 8, you had 8 with a variable x, like 8x equals 32, and you want to get the 8 off of there, you multiply both sides by 1/8 or divide both sides by 8, and you'd get that get that off of there. So you'd only have 1x left. 1x equals 4 is what you'd have left. So those are used all the time in algebra. And we're just about to dive in with chapter 2 tomorrow. So that'll be fun. And I'll use that language while we go, as we go along. Oh, how did I forget distributive? My bad. That's number 5 back here. Distributive is if you have a number just sitting outside the parentheses and there's adding or subtracting going on inside, then that number goes on through. So move my toolbar. So here with this one, let's look at 3 times the quantity 8 plus 5. That means normally you'd use your order of operations and do 8 plus 5 is 13 times 3. Then you'd get 39. But this is just demonstrating the property. So 3 times 8 plus 3 times 5 is another way to write it using the distributive property. And you'd still get the right answer. 24 plus 15 is 39. So you'd get it. And the number can be hanging out on the back or the front. And we know to distribute when there's no operation showing here. Just that number is sitting there kissing up to the parentheses like that. That's how we know to distribute. And we'll practice that a lot also in chapter 2. Hold on. I'm going to go back to the slideshow for these last ones. The current slide. There we go. Okay. This is, if I do it in slideshow mode, see, it doesn't show the answers right away. So the first one is, that's the distributive property, like I was just saying, is that 3 is just sitting there. It gets multiplied to both of those. Who knows what the property, or you want to take a guess at the property for B? Let's just say it out loud. Does anyone know? It's a hard one. What?
5.
5. Yep, 5 is the number. Yep, and the property is multiplied by its reciprocal, so it's multiplicative inverse. Good job. All right, how about for C? What's this one's property? Or maybe we should just figure out what does it equal. Let's do that. This is the associative property for C. But tell me what it equals. Anybody could just shout it out loud and proud. Go ahead.
16.
Yeah, good job. All right, let's do it that way. So that's associative. How about this is associative also, isn't it? What's that one going to equal?
15.
Good, Don. Good job. And then this is that commutative property of multiplication where you can, it doesn't matter the order you do them in, it'll still be the same answer. What's that going to equal?
34.
Yes, great. All right, very good. Okay. So there's the answers to what properties they were. And then they want us to complete the statement using the property. And then we're just about done. So commutative means you can switch the order and they'll still be the same answer. Associative means, it should be associative right here. That means you can move the parentheses and still get the same answer. And then distributive, they have it already distributed, so they're going to pop it back into there next to the parentheses the way it looks like that. Those are the big ones: commutative, associative, and distributive. We use them all the time in algebra, and you've used them before already. So it's nothing surprising. But I did want to do this last story problem. Not the whole thing. Let's just find the area. Don't worry about the distributive property. So I'll read it out loud. And in story problems, sometimes people need to hear it out loud. Sometimes people need to talk it through with someone. Sometimes you draw a picture. So while you're thinking about this one, I'll try to draw the billboard. See if it'll keep letting me. So this looks silly. Sometimes people are like, I can't draw. I'm not gonna. draw. But if that's how you make sense of things, it doesn't matter. It's not like joining the Red Cloud Art Show, you know, it's just how I make sense of it myself with a little sketch. So the width of the billboard is 60 feet. So we know that much. Let's draw 60 feet. And you don't have to do the picture, I'm just showing. With story problems, there's lots of ways to make sense of them. 60, I'll just do this for feet. And you're told that its height is 22 feet less than its width. So the height is going to be the width less 22 feet less than that. So 38. Does everybody follow that okay? Give me some kind of sign if you're on board. Not on the billboard though, that'd be dangerous. You know, they show that sometimes in LA and stuff, people up there on the billboard. Label here. So that's it. Then the area, remember that's length times width. So area, just to review what we talked about earlier, length times width. Or they told us width times height in this case, didn't they? So that's width times height. That don't get confused by their random language. That's how real life works. And so 60 was the width and height is 38 feet. Both are feet. And then you can find the answer. Take length times width, 60 times 38, and I'm going to write it too, just in case. I think I have it, but I want to make sure. Does anybody want to say it? I won't call on you. I won't call you out specifically, but if someone has the answer.
Is it 2,280 feet?
Yes, good job. All right, very nice. Yep, 2,280 square feet. I don't always put the comma. It's not wrong if I forget. You could enter it in WebAssign without the comma too, but sometimes I don't put it, so I'm sorry about that. Anyone have a question about that? And then I'm gonna, I will always check back, double check if I do a problem, like especially if I'm distracted or something. I'd go back and make sure that was in feet. That's in feet. It's a billboard, so it's pretty big. They didn't ask for the answer in yards or anything complicated. So that's it, 2,280. Good job. I think that's the last slide I wanted to go over today. Just going to make sure. So they're saying that what I was saying, go ahead and draw a picture, label it. Those are all really good strategies. Also, when I was a student, and I'm still this way. Yeah, when I'm teaching something that I haven't taught in a while and I do all the story problems the day before and stuff, I rush. I rush through and I skip some of the strategy steps and I sometimes miss something important. So that's just me. So we all know ourselves pretty well by this age that you're at and that I'm at. So we know what to watch out for. Like have a little like a little tiny fairy creature or something in your mind watching you work, saying, "Don't forget to check back," like that. So because it's good, then you'll have your own little, your own little self monitor. So they kept it in that form 60 minus 22. I didn't see the point because we're not using variables yet. So They made it look harder. So the area is 2,280 square feet. All done, my wonderful students. Stop the screen share. All right. Does anyone have any questions about that or concerns? Don't forget, before we go, I promised that, well, we're not going to go. We're going to take a break and then we will do we'll stay logged on with your cameras on to do the quiz. And after that, if you're caught up, you're done. And if you're still working on assignments, you can work on assignments. But I just wanted to show you this. Here we go. I usually do this on my phone, so I don't usually see all these ads. So this is called the Nerdle. It's at nerdlegame.com, and it's a new one every day, just like the word game that a lot of people play, the Wordle. So they have a how-to. Also, let's see there. If you click the question, it tells you how to do it. So you just, first of all, make up an equation, and it uses the order of operations. I know I just showed that fast, but let's say I don't want to take your time up. If I did 35 times 3 minus, that'd be 105, wouldn't it? No, that's not going to work. Hold up. 3 times 5 plus 2, that would be 17 equals. So just make it up off the top of my head just so it would fit and it'd be true. Then those purple ones mean there's a 2, an equals, and a 1 in this situation, but they aren't in the right place. If I did it where, show this again, the 9 is in the right place and the right number in the how-to right there. So if I'd put it in the right place, it would be green. If it's black, it means it's not in there at all. So on my next try, won't use any of the ones that got ruled out. So I'm not going to go through this whole puzzle, but I'm just showing you how it would work. If I did 21 minus 4 times, oh, no times. Minus again then. Minus 21 minus 4 is 7. Oh, let me show you a wrong one. Minus 4 equals 1. If you do your math wrong and then enter, it'll say, that doesn't compute. You didn't do that right. But it's good. If you like that kind of stuff, it's good practice. So any day any of you want to do this for extra credit, go through it and send me the screenshot at the end, or the share, it says copy to share. Just send me the share if you do it. I'll have to take your word for it that it was you, but I don't care if you do it with your friends or your kids, or just make sure you're involved. I don't want you to just have someone else do it for you. It won't be as satisfying. But again, that's at nerdlegame.com, and I'll put the link on the Moodle too, in case anyone forgets. But that'll be every day you want to do it. It's every single day there's a new one, and it's 3 points anytime. Did I say 3 or 4 earlier? 3 points anytime you want to do the Nerdle, and just send it to me. I'll give you extra credit. Okay, let's take a break. Let's just do a 5-minute break and come back for the quiz so that you can get right into it. It's already open. If you want to just go ahead and start it, you can. I need to ask you to keep your cameras on while you're doing tests, if you can. If you can keep your camera on, I'm supposed to be proctoring and keeping an eye on you. But then once you're done, I'll be watching in WebAssign also, so I'll know when you're nearly done. But when you're done, just message me or say, hey, Jen, I'm done and I'm going to go now, or I'm going to work on my assignments.